Hey, Physics Honors, this is Mr. Aiden. This is Mass Energy Equivalence. This is the main last content piece of our physics course, which is awesome. And this is why we end with the mass energy equivalence is it is the culmination of the entire physics course all in one little equation. So let's get to it. We have what we know is this theorem that the fundamental source of all energy in the universe is the conversion of mass into energy. And who came up with this? Otherwise known as Albert Einstein. In 1905, Albert Einstein, a little patent clerk, came up with his 1905 papers. He would be given the Nobel Prize about a decade and a half later. And this was his theory of relativity, and he came up with an important concept that mass is a measure of the energy of an object. Not just the inertia, but mass is a measure of the energy of an object. And if you think, we've been kind of thinking of mass as matter, inertia, we've been thinking of energy as energy, and we haven't been thinking that they are the same thing. And that is something Einstein saw. And so he ultimately saw that the source of all energy in the universe is the conversion of that mass into energy, and that energy into mass. And it came to one simple equation, E equals mc squared. You've seen this equation before. It's called the mass energy equivalence equation. E equals mc squared. E means energy in joules. Mass is mass in kilograms, and c is, of course, the speed of light. And what's the speed of light that we know is, or agree upon, is 3 times 10 to the 8th meters per second. Which means, if we think about it, we've been just taking a look at, we know there's a conservation of mass, of matter. Especially in chemistry, we will see that over and over and over again. There's a conservation of matter. There's a conservation of matter. We've taken a look at there's a conservation of energy, right? From gravitational potential energy to kinetic energy, from kinetic energy back up to gravitational potential energy. Well, which one is it? Is there a conservation of matter, or is there a conservation of energy? Well, believe it or not, they're the same thing. Because mass, or matter, and energy are the same thing. They're just two sides of the same coin. And so it's really the conservation of mass energy. So let's get to a problem and see what this might look like. We want to know what the energy equivalent of 5 kilograms of matter is. And so we're going to look at E equals mc squared. And so energy equals mass. The mass here is 5 kilograms. What is 5 kilograms in your daily life? Well, that would be about 11 pounds. 11 pounds would be about 5 kilograms. And the speed of light is 3 times 10 to the 8th meters per second. And we're going to square that guy. So we're going to square the speed of light, and then we're going to multiply it by 5. And that gives us an energy equivalence in joules of 4.5 times 10 to the 17th joules. That's 4500000. There's 16 zeros after that 5. It's a big number for joules. Now, that means nothing to you, does it? It doesn't really mean anything to you at all. Is 4.5 times 10 to the 17th joules. It looks like a big number, but joules could be a big number, right? Well, let's put that in electron volts, because we've been dealing with electron volts, and electron volts have been in kind of a way to look at our joules in a nice way. We have 3 electron volts or 5 electron volts, and that's what we've been working with normally. Well, we know for 1 electron volt, it's 1.6 times 10 to the negative 19th joules, which means the mass energy equivalence of this 5 kilograms of matter is on the order of 2.8 times 10 to the 36 electron volts. It is crazy huge. Crazy huge. To put it in some perspective, if you took the mass energy equivalence of a pickup truck, it could fuel the entire United States. It's the United States' energy consumption for an entire year. Is that amazing or what? There is so much energy inside a piece of matter that even the amount of one pickup truck, the amount of energy consumed in that equivalent, could fuel the entire United States for one entire year. But we normally don't take a look at the mass energy equivalents of big things like 5 kilogram masses or pickup trucks. We are normally doing what we call nuclear reactions. And those nuclear reactions, we can actually get the energy from those nuclear reactions by moving them close to the speed of light and having them bombard each other, and we end up getting a mass energy equivalent of these particles. So we want to know, what's the mass energy equivalent of a neutron? So we have E equals mc squared. What's the mass of a neutron? A mass of a neutron, if you remember, was 1.67. Sorry, I wrote that down wrong. 1.67 times 10 to the negative 27th kilograms. And the speed of light is 3 times 10 to the 8th meters per second squared. So we're going to take 1.67 times 10 to the negative 27th times 3 times 10 to the 8th. We're going to square that 3 times 10 to the 8th, and we're going to multiply them, and that ends up giving me 1.5 times 10 to the negative 10th joules. And remember, I can change that into electron volts. For every 1 electron volt, there's 1.6 times 10 to the negative 19th joules. So we can divide that by 1.6 times 10 to the negative 19 joules. And we end up getting a mass energy equivalence of 9.4 times 10 to the, let's see, 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the 8th electron volts. It is insanely huge, and you can see that's why when we have a nuclear reaction, we can just have an amazing amount of energy. A nuclear bomb gives off an insane amount of energy equivalence because we have the mass energy equivalence equation coming into play here. E equals mc squared. Well, I'll see you later, guys. Catch you on the flip side.